Alright, what's up, guys? So, today we're going to be talking about stoichiometry, specifically how to convert from moles to atoms. So, without further ado, let's get started. So, we have a problem here, and it asks us to compute both the number of moles of atoms and the number of atoms in a 10-gram sample of aluminum. So, they're asking us to find the number of moles and the number of atoms in a 10-gram sample of aluminum. So the way we set this up to solve is the first thing we want to do is we want to write out what we know. Well, we know that we have 10 grams of aluminum. So let's write that down. 10 grams of aluminum, and I'll abbreviate it AL. And we want to convert that. Let's first do to moles, and then let's do atoms. So we want to let's convert it to moles. So we have 10 grams of aluminum, and we want to convert it to moles. So we want to get rid of our grams, and we want to convert it to moles. Well, is there any gram to mole ratio that we could possibly use to make that conversion? Well, absolutely there is. If I divided this by grams of aluminum, and if I, in my numerator, put what I wanted to find, which is moles of aluminum, what I could use is I could use that 1 mole is equal to the molar mass of aluminum. So the molar mass of aluminum, if we reference our periodic table, would be aluminum 26.98 grams per mole. 26.98 grams per mole. Let me rewrite that. So, using this conversion, I can cancel out the grams because, this is 10 grams of aluminum in the numerator and this is grams of aluminum in the denominator. These two units cancel out. We're left with moles of aluminum, which we want. And all we have to do is we have to do 10 grams divided by 26.98 grams of aluminum. So 10 grams of aluminum divided by 26.98 grams of aluminum. And that gives us 0.37, and let's follow sig figs here. There are 3 sig figs, 10.0, 1, 2, 3, 3 sig figs, so 0.371 moles of aluminum. Alright, so we solved part A of this question. Now let's go on and solve part B, and I'll do it in white. So now they want us to find the number of atoms in a 10-gram sample of aluminum. Now, could we just go from this mole conversion to atoms? Absolutely, but why don't we just go back from the 10 grams of aluminum and solve it from there? So 10 grams of aluminum. And really, it'll just be one more extra step. So we want to get rid of grams of aluminum, so we know grams of aluminum has to be on the bottom so that the numerator and denominator units can cancel out. And on our top, the only conversion we can make from grams is moles of aluminum. So we can use the same conversion, 26.98 grams per mole, so per 1 mole of aluminum. This is just the molar mass of aluminum. That's simply all we're stating, 26.98 grams per mole, times the moles of aluminum, because keep in mind, we want to get atoms, the number of atoms in a 10-gram sample of aluminum. So we don't want moles anymore. We want moles to cancel out, so we have to put moles in the denominator so that the numerator and denominator can cancel out. And we want to get into atoms, so let's put atoms of aluminum. Atoms of aluminum. So what conversion factor can we use here? Well, keep in mind, probably the most important conversion factor you'll have in all of chemistry is Avogadro's number. Avogadro's number states that 1 mole is equal to 6.0 2 times 10 to the power of 23 molecules or atoms of whatever the substance is that you're concentrating on. So we know that 1 mole will be equal to 6.02 times 10 to the power of 23 atoms of aluminum. So if we did this conversion and we typed it into our calculator, we'd get 10 times 6.02 times 10 to the power of 23. Divide that quantity by 26.98, and you should get 2.23 times 10 to the power of 23 atoms of aluminum. And keep in mind, sig figs are very important when it comes to stoichiometry. Here they tell us it's a 10.0 grams sample of aluminum, 123 sig figs. So we know that both of our answers have to have 3 sig figs. Now, could I have went from the 0.371 moles of aluminum to atoms just by multiplying this by moles of aluminum and atoms of aluminum, and do the 1 over, or 6.02 times 10 to the 23rd over 1 and get the same answer? Absolutely, but I just wanted to do it the long way to show that there's this extra step that we have when it comes to finding the atoms when you're given the grams of a sample. So hopefully this video better clarifies the moles to atoms conversion, which we can show here, the moles to atoms conversion, and which we can also show in this step, and how we utilize Avogadro's number to make this conversion. Thank you for watching this video, and I hope you tune in for more.